Number 57. This problem is actually from section 6.2. So let's look at this problem. It says here we have the graph given for a function f. And the instructions are, now note that the graph is for a function f. And now we have a function g that's defined as follows. G of x is equal to the definite integral of f of t dt from 1 to x. On a copy of the figure, sketch the graph of the function g. To help us sketch the graph of the function g, it helps to make a table like the one that I'm about to make here. So let's start with something really easy. When x is equal to 1, what do we have? We have g of 1 is equal to the definite integral from 1 to 1 of f of t dt. Do you understand why we have a 1 here? Because if you look at our function g of x, the upper limit of integration is whatever the input x is. So when the input x is 1, the upper limit of integration is 1. And when you have a definite integral where the lower and the upper limits of integration are equal to each other, the definite integral is equal to 0. So we will have the ordered pair 1, 0, and we can go ahead and plot that point on our graph here. We have the point 1, 0 right about there. So now I'll do the next easy point. Let's find g of 2. How do we find g of 2? So here's how we find it. So we're going to go ahead and change the input for our function from 1 to 2. So now our function is evaluated at the input of 2. So the upper limit of integration now becomes 2. So how do you interpret the definite integral of f of t dt from 1 to 2? You're going to look at the graph of f, and you're going to interpret that as the area between the graph of f and the x-axis from x is equal to 1 to x is equal to 2. Now, you're just approximating, so you can kind of see that that's approximately a triangle, and the area of that triangle would be 1/2 base times height. The base is 1 unit, the height is 2 unit, so what we have is 1/2 times base times height. 1 times 2 is 2, half of 2 is 1. So it's going to be approximately 1. Not exactly, but approximately. So now we have a second ordered pair that we can plot on the graph of f. So we're going to have the first ordered pair is 1, 0. The second ordered pair is 2, 1. Let's take a look at one more here. What about g of 3? Well, let's do g of 4 because I think that'll be a little bit easier for me to explain. So, but you do it the same way. So whatever the x value is, you look at your function, g of x is equal to the definite integral of f of t dt from 1 to x. So whatever the input is, that's what the upper limit of integration becomes. So if we're working with x is equal to 4, then we're going to have this. The upper limit of integration will become 4. And let's go ahead and look at that. So how do you interpret the definite integral of f of t dt from 1 to 4? You interpret that as the area between the graph of f and the x-axis from x is equal to 1 to x is equal to 4. So again, we have this triangle that we had earlier, and we said the area of that triangle was about 1 unit. And then we have this region below the x-axis, and that's below the x-axis, so we're going to interpret that area as negative area. And that looks to be, we're going to have to approximate here, it looks to be more than -1. Maybe like, well, it looks to be more than 1 in absolute value terms. So the area could be something like -1 and maybe like 1 1/4 or something. So you have positive area from here, and then you have negative area from here. The positive area is about 1. The negative area is about 1 1/4. So when you add 1 and negative 1 1/4, you get negative 1/4. So you get negative 1/4. And then you're going to plot that point. So right now we have 3 points. We have 1, 0, we have 2, 1, and we have 4, negative 1/4. And you continue in that manner. What about when x is equal to 0? Now I want to focus on that next, because what happens is this. What happens when x is equal to 0? The upper limit of integration will become 0. But now you have a situation where the upper limit of integration is less than the lower limit of integration. So what you want to do now is you want to reverse the limits of integration so that you will have it from 0 to 1. But when you reverse the limits of integration, there is a property of definite integrals that says we have to now multiply by negative 1. So to find g of 0, you have to find the area between the graph of f and the x-axis between 0 and 1. So that would be the area of this region. So that's 2 units and maybe like a little bit more than 2.5. But then because of this negative 1, you have to multiply by negative 1. So you would have negative 2.5 for g of x when x is equal to 0. So let's look at the 4 points that we have on the graph of g. We have 0, negative 2.5. We have 1, 0. We have 2, 1. And we have 4 and negative 1/4. And when we connect those 4 points, we get something like that. And then, of course, you would have to fill it in by finding other values of the function for like x is equal to 5, x is equal to 6, x is equal to 7, and x is equal to 8. But what I can see is that over here, I'm going to have positive area. So if I go beyond 4, I'll be adding positive area to whatever I have here. So if I had to roughly estimate the graph, it would do something like that. So now we're looking at part B. So in part B, we have a different function from what we had in part A. In part A, we had g of x, and in part B, we have h of x, which is the definite integral of f of t dt from 1 to x squared minus 1. Find h prime of 2. So to find h prime of 2, you can first find h prime of x. So we have h of x is equal to the definite integral from 1 to x squared minus 1 of f of t dt. And to find h prime here, we're going to have to use the second fundamental theorem of calculus in conjunction with the chain rule, because what we have here is a composition of two functions where the inside function is x squared minus 1. So the derivative here would be, using the second fundamental theorem of calculus, it would be our integrand evaluated at x squared minus 1, the upper limit of integration, and then we're going to multiply by the derivative with respect to x of x squared minus 1. So what is h prime of x? H prime of x is equal to, this derivative is going to give us 2x multiplied by the function f evaluated at x squared minus 1. So now how do we find h prime of 2? Well, what we do is we take x and we write that in place of x here and here. So we're going to have h prime of 2 is 2 times 2 multiplied by f of 2 squared minus 1. 2 squared is 4, 4 minus 1 is 3. And what is f of 3? To find f of 3, you look at the graph of f. Here's x is equal to 3, and f of 3 is negative 1, as you can tell from the graph. We have the point 3, negative 1 on the graph of f. So we have 2 times 2 is 4, and f of 3 is negative 1. So the answer is -4 for h prime of 2.